Right, so visiting that question about the number of ways that you could choose two players to go in an A flight and a B flight out of a possible 5 players. So we're going to approach this problem using lists to start. And if we take a look at if player A is going to be chosen for the A flight, well then for the B flight you can choose B, you can choose C, or you can choose player D or player E. So if A is chosen for the first flight, then you have 4 choices left for who is going to go in the B flight. Now, if you choose player B to go in the A flight, then you've got then 4 other choices for who goes in the B flight. So if you could have player B in the A flight and player A in the B flight, player B in the A flight, and player C in the B flight, and so on. So there are 4 possibilities or 4 arrangements where player B is in the A flight. And if player C is chosen for the A flight, then again there's 4 possibilities or 4 arrangements where player C is in the A flight. One where A is in the B flight, one where B is in the B flight, and so forth. And so if we continue down, you can see that if player D is in the A flight, there's 4 possibilities. And if player E is in the A flight, again, there's 4 possibilities. So for the total number of possibilities, then, if you're going to choose two of 5, and the order is important, then there is 20 possible ways, 20 arrangements. Now, if we're going to have a C flight, then here's all the possibilities where A is chosen for the first flight, and we have 3 possibilities then. If A is chosen for the first flight and B is chosen for the second flight, then we could have C in the third flight, D in the third flight, or E in the third flight. And if you continue through all these possibilities, then there is 12 where player A is in the A flight. Similarly, there are 12 where player B is in the A flight, 12 where C is in the A flight, 12 where D is in the A flight, and 12 where E is in the A flight. So the total possible ways, if you're going to choose 3 players, of 5, then there are 60 ways we can do this. And this is our 5 times 4 times 3. Now, we're going to start using a new method of showing this, a new mathematical method of showing this, and it's called a permutation. So permutations. Suppose you have n objects to choose from, but only want to select some rather than all of them. So in the case of the badminton tournament, you have 5 to choose from, but you only want to select 2 in the first case. There is still a sequence of choices to be made. In this case, not all the elements in the set are selected. A permutation is an ordered arrangement of objects selected from a set. So the permutation of n choose R, which is also written as subscript n, capital P, and subscript R, represents the number of permutations possible in which R objects are selected from a set of n different objects are arranged. So, for example, if we have the permutation of n choose R, well, if we're going to choose then 3 out of the 5, then it's 5 factorial over n minus r factorial, which in this case is going to be 5 minus 3 factorial. So this is 5 factorial over 2 factorial, which simplifies to be 60. So going back to the question we just were looking at, if we have two different player seed orders, and we've got 5 players to choose from, then we could use the permutation of 5 choose 2. So that means that we're going to choose 2 of our 5 players. Well, this is 5 factorial over 5 minus 2 factorial, because we're choosing 2. And this ends up simplifying then to be 5 times 4, or 20, which is what we saw before when we listed them all. So if we take a look at the second question we asked, where we have 3 players to choose out of the 5 for the A, B, and the C flights, well, this is going to be the permutation of 5 choose 3, which is 5 factorial over 5 minus 3 factorial, which is 5 factorial over 2 factorial, which again simplifies to be 60. So there are 60 ways that you can choose 3 players out of 5 to go to the tournament. And here we have to emphasize that the order that you select them in is important, because choosing A for BC is different than choosing CBA in this case, because you're choosing A for the first flight in one case and C for the first flight in the other case. So we're going to calculate some permutations. There are 15 players on a school baseball team. How many ways can the coach complete the 9-person batting order? So you're going to pick 9 people to go up to bat, and the question is, how many different ways can the coach select the batting order? Okay. Whenever you count the ways that different objects can be put into arrangements of any size, the order in which the objects are selected is an essential consideration. Order matters in this situation. We must calculate the number of arrangements that contain 9 items from a set of that contains 15. So this is going to be the permutation of 15 choose 9, which is 15 factorial over 15 minus 9 factorial, which is 15 factorial divided by 6 factorial, which is going to be this, which simplifies to 15 times 14 times 13 times 12, etc., down to times 7, because everything after the 7 is going to cancel out by what's divided through in the denominator. And so we end up with 1,816,214,400 possible ways that we could select the order for this baseball team. So now, if you want to take a moment and calculate each of these. So 5 factorial is 120. The permutation of 5 choose 3, well, we saw this before, is 5 times 4 times 3, which is 60. 8 factorial times 6 factorial simplifies to be this, which is 29,030,400. 5 factorial over 4 factorial is 5. The permutation of 10 choose 3, so if we've got 10 items to select from and we're going to choose 3, and order matters, then the number of ways that this could occur is going to be 10 factorial divided by 7 factorial, which simplifies to be 10 times 9 times 8, which is 720. Okay. If we've got 7 items to choose from and we're going to pick 5, the number of ways that we could do this, and again, order matters here, is going to be 7 factorial divided by 2 factorial, which is 2,520.